Okay, IGGY members, today we are going to be going through a year 10 and 11, so GCSE level titration question. Okay, so now titration's a very common problem that you'll be coming across. I know for a fact that you do it in your ISAs if you do those, and also they crop up in exams quite a lot, no matter what exam board you're on. Okay, so the best way to teach a titration question, I think, is to crack straight on with an example. So I've got one up on the board here. So in a titration, we are taking 25 centimetre cubes of HCl, hydrochloric acid, and using it to neutralise sodium hydroxide. To be more specific, sodium hydroxide we have 30 centimetre cubed, and that is at a concentration of 0.23 moles per dm cubed. Okay, so there are two important things to note before you start on this question. The first is that organisation of your data is very, very important. Okay, and then the second is this equation right here. Okay, so what we have here is we have the concentration of a solution is equal to the number of moles of the sample divided by the volume. Okay? Now this, if you want a handy way to rearrange this equation, okay, we can kind of rearrange it. So if we want to learn the concentration, we can just do N over V. However, if we wanted to rearrange that somehow, we might draw it in a triangle. So if I could put C here, N here, and V here. Draw a triangle around it, like so. Okay, so now, using this, we can figure out which one we want to calculate. So if I were to do concentration, I'd hold my hand over here, and that shows us that we've got N over V. If we wanted the volume, we could cover that, and it would be N over C. And then if we wanted N, we could cover N, it would be C times V in this case. Okay, so that's a handy trick, and that works for any kind of general equation where we have three factors, for example, moles equals mass over the molar mass. Okay, so on to the actual question. What do we have? So I've drawn up a table, and we're going to jot down what things we know. So we know the volumes of both, so I'll jot them in here. We have volume of hydrochloric acid is 25 centimetre cubed, and now generally in chemistry we work in decimetre cubed. Okay, so we need to divide this by 1000, which gives us 25 over 1000, okay, which gives us 0.025 dm cubed. Okay, and we also have the same for sodium hydroxide, so volume equals 30 centimetre cubed in this case, which again we divide by 1000 to get 0.030 decimetre cubed. Okay? So the next thing we know is the concentration of sodium hydroxide. So the concentration equals 0.23 moles per dm cubed. Okay? So what we're trying to calculate, okay, is the concentration of hydrochloric acid. This is what we want to know from this question. The number of moles we can get from the equation down here, so the chemical formula here. So this equation is a neutralization reaction, so we have hydrochloric acid plus NaOH gives sodium chloride salt and water. Okay, so what we're trying to work out from this is the concentration of hydrochloric acid. Okay, so the first thing we need to do is calculate the moles of what we've got. Okay, so we know concentration and we know volume of sodium hydroxide, so that means we can pop them into our equation. So we need N. Okay, so we can use our triangle up there, and we said if we need N, we can do C multiplied by V. Okay, so if I pop over here, we can do that calculation. So N equals 0.03 times by 0.23. Okay, and then that will be our N. So if I pop over, just double check I've got that number, and that gives us 0.0069 moles. Okay, so now we have that, we need to refer down to our equation down here. Okay, so we've got one HCl molecule reacts with one sodium hydroxide molecule to give one sodium chloride and one H2O. Okay, so this tells us that if we have 0.0069 moles of sodium hydroxide, that means that amount will react with the same amount of hydrochloric acid. So from that, we know that this N also equals 0.0069 moles. Okay, and now it's a fairly simple calculation. To calculate the concentration here, we know N of hydrochloric acid and we know V of hydrochloric acid. So we can do that again over here. Draw a line under there. So we have C equals N over V equals 0.0069 divided by the volume, which is 0.025. Okay, and the units there we've got moles and decimeter cubed. So then you can see how this will become a concentration because it will be mole per dm cubed. Okay, and if we do that calculation, our answer should come out at 0.276 mole per dm cubed. Okay, and so that would be our concentration. Now that's a very general titration question. You might be asked to calculate the number of, the volume for example. It might give you a concentration for hydrochloric acid instead of a volume, and then it might ask what volume would be needed to calculate, to neutralise that sodium hydroxide. But either way, it's just a matter of rearranging this last equation using our formula triangle up there.